Hey guys, so for today's notes, we're doing properties of inverses. So we started inverses yesterday, and so today we're going to find the properties. So we know that one of the properties is if f of g of x equals x and g of f of x equals x, then f and g are inverses. Some other properties: the domain of f is the range of the inverse of f, and vice versa. So my pen stopped working. There we go. And the range of f is the domain of the inverse. We'll talk about some more as we go along. So for this first section, it says find the inverse R of each relation S. So these are not functions, they're relations. So they're giving us this set of points, a number 1 and 2, and they're telling us to find the inverse. Remember that when we found the inverse given the equation, we switched x and y. So when we're giving it in function notation, we switch x and y. It's the same thing when we're given it as a relation and a set of points. So I'm going to switch my x and my y. So we're finding the inverse. They told us it's going to be named R. And I'm just going to switch the x and the y. So 0, 1, 4, 2, 6, 4, 6, 7, and 10, 9. Remember, we said that the domain of f is the range of f inverse. So that applies even with our relations. The domain are my x values, remember? My x value now becomes my y value. So that means that the domain is now the range, and the range is now the domain. Same thing with number 2. We're going to write the relation R, which is going to be the inverse of S. So we've got this set of points. All we're doing is switching the x and the y values. 2, negative 3, 4, negative 5, 7, 2, and 3, negative 4. So we switched our x and our y's to change our relations to their inverses. We'll do the same thing on numbers 3 and 4. When I'm given a table, it's a set of points with x and y. So this is the set 1, 5, 2, negative 2, 0, 1, and 5, 3. So when I'm writing the inverse of number 3, it'll be the set 5, 1, negative 2, 2, 1, 0, and 3, 5. Then for number 4, it's the same thing. So this is the set of points 3, 0, 4, 7, 2, negative 3, and negative 1, negative 1. So my inverse would be the set 0, 3, 4, 7. Oops, this should be 7, 4. 4, 7, 2, negative 3. I switched them on accident in the original. Let me go back and change that. I should say negative 3, 2. There we go. So these two down here are my inverse functions, or relations, sorry, my inverse relations. Now on 5 and 6 it says for each function write the equation of the inverse. So this is what we were doing yesterday. So we know they are functions. And we want to write the equation of the inverse as f inverse of x. Anytime I'm given f of x, it's the same thing as saying y. So y equals x minus 3 is what I'm given. This is the original function. I'm switching x and y now. And then I'm solving for y. So this is now x equals y minus 3. My next step, solve for y. So this would be add 3, x plus 3 equals y. So I do have y isolated on one side. So when I write the inverse, it's going to be the inverse of f is equal to, and then x plus 3. Then on number 6, we'll do the same thing. So I'm going to switch x and y. First I'm going to write it with a y. That way I know where the y is. Then I'm going to switch them. So x equals 1/2 of y plus 5. I'm going to subtract 5, get rid of that constant. I get x minus 5 equals 1/2 y. Still need y by itself, so I'll multiply by 2. This is going to distribute that 2 here. So 2x minus 10 is equal to y. Y is isolated because it's the only thing on the right. I'm going to write this as the inverse of f is equal to, and then 2x minus 10. So this is what we did yesterday again, where we're just finding the inverse by switching our x's and our y's. We're going to do 2 more. On number 7, we're going to start by making this a y, like always. So we've got y equals x squared plus 1. Now we're going to switch the x and the y, so x equals y squared plus 1. If you're starting by rewriting with a y, make sure that you don't stop there and think, oh, I already did it, I solved for y. We still have to switch the x and the y and then solve. So we're going to take away 1. We get x minus 1 equals y squared. In order to get this y by itself, I have to do the opposite. So I'm going to take the square root of both sides. Square root of x minus 1 is equal to y. Y is isolated, so it's the only thing on the right side. Now I can write the inverse of f is equal to the square root of x minus 1. Number 8, rewrite it with y equals square root of x plus 1. And then switch x and y. X equals the square root of y plus 1. I cannot move this 1 over. I can't go, oh, that's minus 1, minus 1. No, it is underneath a radical. So first thing I need to do is get rid of that square root. So I end up with x squared on the left is equal to, these two cancel each other out, so I just have y plus 1. Subtract 1 from both sides now, since it's not underneath the radical anymore. I get x squared minus 1 is equal to y. Y is isolated, so I can write f inverse of x is equal to x squared minus 1. Now here it says for each function, state the domain and range of the function. Then state the domain and range of the inverse, f inverse of x, using set notation. So it says set notation. That's going to be the one with the squigglies. So we're going to state the domain and the range of this original function. So this is my domain, this is my range. So for my original function, the domain of f of x is the set 2, 4, 6, 8. So the set of all my x values, and then the range of f of x is -2, 0, 5, 1, all my y values. Now I need to find the domain and the range of the inverse. Remember, we're switching our x and our y values. So the domain of the inverse of f of x is going to be my y values. So -2, 0, 5, and 1. The range of my inverse will be my x values. So the range will be 2, 4, 6, and 8. So when we're finding the domain and the range of our inverse, we're going to switch between what we had before. So the domain becomes the range becomes the domain. Alright, so on number 10, we're finding the domain and the range of the original function first. So the domain of f of x is equal to, we know we find our domain by going left to right. And I see an arrowhead here, so my domain is going to continue on. So it is, we're going to write it in set notation. So it is the set of all x's such that x is greater than or equal to -3. The range of this original function is the set of all y's such that, so let's look. The y values looking up and down stop right here. There's no lower value than right here. And they go up, and there's an arrowhead, so they're going to continue on and on and on. So it's the set of all y's such that y is greater than or equal to, since we have a stopping point on the lower bound, and this lower y value is 0. Now we saw before that the domain of the inverse is the range of the original function. So my domain will be the set of all x's such that x is greater than or equal to 0. The range of my function will be the set of all y values such that y is greater than or equal to -3. So they just switch. Now let's look at these funky looking graphs. So I have this one here. This is the first one we're looking at. And I'm trying to find the domain of the original function first. Domain of the original function is my x value. So it starts here and it goes here, but it has an arrowhead. So it's going to continue in this direction. It's kind of slanted. It's going to continue in this direction as well. So my domain starts at -4. We're going to write these in interval notation, which is the one with the brackets or the parentheses. So here my domain starts at -4 with an open circle. So we see this open circle here. So I need to have a parenthesis. And it stops at infinity because we said it's going to keep going on and on and on. For the range, I'm going to have where it starts on the lower bound is here, and I have that arrowhead, so it's going to go on and on and on as well. So my range starts at 1, and that 1 is included because it is a closed point here. So I'm going to have a bracket, and it goes on to infinity. We said that when we're finding the domains in the range for the inverse, that they're going to switch. So my domain will go here, my range will go here. So my range becomes 1 to infinity, and my domain becomes 1 to infinity, and my range becomes -4 to infinity. So let's try that again on the second one. We have this absolute value function here. We're going to find the domain. I see arrowheads. Arrowheads mean I'm continuing on and on and on. The domain looks like it's going to go forever in either direction. So my domain is -infinity to +infinity. My range has a lower bound. It stops here, but it is going to continue because of those arrowheads. So my range stops at this value right here, which is -5. So the lower bound on my range is -5. The upper bound is infinity. And then for these inverses, they will switch. So the domain becomes the range, which is -5 infinity, and the range is going to take on that domain. So -infinity to +infinity. So we're getting some good practice with domain and range, and also working with our inverses here. So on this third one, we're going to take the domain. I see arrowheads in the left direction, and then a stopping point here on the right. So my domain is the set -infinity up to 4, and it is a hard point, a hard stop, so we've got brackets. So -infinity to 4. My range, I see the lowest point is here, and then we're continuing on in this direction. If you're not sure if it's going to continue upward, kind of extend that line and see, is it getting higher? If it is getting higher, then yes, it is extending. My lowest value is 0. My highest is infinity. And then, like all the other examples, we're just going to switch those two for the inverse. Oops. Now on the next one, we've got this weird piecewise function. So the domain is my left to right. This is my stop on the left. This is my stop on the right. So on the left, I have an open circle, so I know it's going to be a parenthesis. My x value is -5. And on the right, I have a closed circle, so it's going to be a bracket, and that value is 5. My range, my lowest value on the range is here. My highest is up here. So my range, I have a closed circle on the same value as an open circle. So if there is a closed and open on the same point, same value, take the closed, because that value would be included in my range. So it's going to be a bracket. So a bracket on -2, and it goes up to +2. So then we'll switch them. We got -2 to 2, closed, and then -5 to 5, 1 parenthesis, 1 bracket. On the next one, we just have a set of points. So when you have a set of points, we're going to have to work in set notation. So my domain, let's write these points out, because it was hard to see them. There's a point right here, which is -3, 1.
Pardon the interruption, but the students who take the shuttle fourth period, please report to the bus porch. The students who take the shuttle during fourth period, please report to the bus porch. And teachers, workshop Wednesday will be during C and D lunch.
Sorry about that. So we're going to write out these points. We have -3, 1. We have -2, 0. We have a point here on 2, -5. And then a point here on 1, 4. And this last point here on 5, 1. That way it's easier to see what my x values are and my y values. So -3, -2, 1. I'm going to try to go least to greatest as much as I can. And 5. The range is going to be my y values. Got 1, 0, 4, -5, 1. Then for my inverse, I'm going to switch them. So 1, 0, 4, -5, 1. My range, -3, -2, 1, 2, 5. So here's an important thing. We're going to fix this problem. If I told you I had a set of people that I was inviting over, and I said it was John, Mike, David, and John, do I have to say John twice? No, you'd make fun of me for saying John twice. You'd be like, you already said that. So it's the same thing with our, with our sets. Same thing with our sets here. So in this one right here, I have 1 and 1. I don't have to say 1 twice. It's like saying I'm inviting 1 to the party. Oh, and I'm also inviting 1 to the party. We already know. So we can close that without repeating that 1. It's not going to mess up your answer. It's just saying that 1 was already included. I don't have to say it again. Alright, and then we've got this funky graph here. We're going to find the domain and the range of this one. So here, my domain, as always, goes left to right. So here's my lowest value on the x-axis, and there's my highest value on the x-axis. So left to right, those are my highest and my lowest. So that means in interval notation, I'm on a point, so I'm going to have a bracket. This x value is -4. It's hard to see. And then my highest x value here is 3, and it is on an open circle. It's the only one, so it is a parenthesis. And then my range, lowest value I see is here, highest up to here. They're both open circles, so my lowest value is -5 with a parenthesis, and my highest is a 5 with a parenthesis. And then for the inverses, we will switch them. So -5 to 5 and -4 to 3. And then last one, we've got this line here. It's hard to see. Let's see if I can. Alright, so here we got this line. I define the domain and the range. So if I have a line that's going straight up left and right, my domain is all real numbers, -infinity to +infinity. If I have a line, that's going straight up left and right, my range is only one value. My range is y equals 3. So it's the set that only contains 3. So when I switch them, my domain would be the set that only contains 3. and my range would be negative infinity to positive infinity. So then for your homework assignment for today, we've got these 2 pages. I don't want to give you a lot to do. So we're going to use function composition to determine if they are inverses. This is where we're using f of g of x equals x and g of f of x equals x. Just because they say h of x and h of n doesn't mean that this definition changes. It would just be the first one plugged into the second one equals x. The second one plugged into the first one equals x. So it's the same process. I'm only going to give you 1 and 2 here. So 1 and 2. And then finding the inverse, let's do 9 and 12. And then forget about this bottom part. Since this is the weekend, you'll just have 4 problems, sorry. So we'll do 9 and 12, 1 and 2. Oops. So 1, 2, 9, and 12, and then you'll be done. As always, make sure that your name is visible on both pages in order to get credit.